Yeah, can you hear me?
Yes, sir.
Okay, fine. So, yeah, so we are going to begin the class now, awaiting others to join. So,
Yes, I pray also.
now, inshallah, today what we'll be treating is, sorry, somebody's coming in. Who is that? Nazida. Can you see the screen? Let me share the screen. Can you see the screen now? Can you all see the screen now?
Yes, sir.
Hello?
Yes, sir.
Okay. So, I want to believe that you've all done the tasks I gave you yesterday. Who did it? Who tried to review chemical bonding among everyone here? Do you have anybody who studied chemical bonding with the little time that we
Yes,
had? Okay. Were you able to pick questions from past questions? Were you able to get questions from the past question?
I
Uh,
only saw because of when I came back to school this afternoon. That's when I started doing it.
okay. Now, what about others? What about others? Did you check chemical bonding? I can't hear anybody saying anything. That means you did not look at the topic on our own.
So I looked at it, sir, but not. I know.
Okay, chemical bonding. Let's begin. So, what is chemical bonding itself? Has to do with the combination. It involves the process whereby atoms combine together to attain their stability. So, when you check out for atoms, you get to realize that these atoms, most of them are either metals or non-metals. So, and many a time they need to either lose electrons, share electrons, or gain electrons to become stable. So the ability whereby atoms are actually combining together to attain stability to form a force of attraction. That's what we call bonding. So chemical bonding is actually a force of attraction. Are we there? Force of attraction that binds atoms together, atoms or molecules that bind atoms. Let me clean that part, please. That bind atom or molecules together, right? To attain stability. To attain stability. So that's what we call chemical bonding. So it's just like a force of attraction that helps to bind atoms together. You can have an atom A and atom B bonded together to form AB. Okay, so that force of attraction that binds those two atoms together, that's called what? The chemical bonding. Is that understood?
Yes, sir.
Yes, sir.
Now, basically, we have two major classifications. There are two classifications of chemical bonding. So, the first one is considered the intramolecular bonding. Intramolecular bonding. Are we together?
Yes, sir.
And the second one is intermolecular bonding. So the intramolecular bonding examples here, I'm still going to discuss it in details. So we have, okay, let me talk about that here. So we have intra, intramolecular bonding. So the intramolecular bonding is like a force of attraction, is a force of attraction that bind atoms together in the formation of molecules. In the formation of molecules. So what do we mean? When you have one atom together, when we have an atom A plus atom B, both atoms are combining together to give us AB. Am I communicating? Somebody is joining. Let me
Yes,
have
sir.
it. Who is that joining?
Yes, sir.
Yes, sir.
Who is that person trying to join? Is there anybody? Okay, I thought somebody was about joining. So let's continue. So when you have atom A and atom B trying to combine together to give us AB, that force of attraction is called what? Intramolecular bonding. Is that clear?
Yes, sir.
Yes,
So
sir.
for example, we can have an atom of hydrogen plus another atom of hydrogen, both combining together to give us a molecule. So this force of attraction that binds these two hydrogen together to give us this is what? An intramolecular bond. Does that make any sense?
Yes,
Because
sir.
Yes,
it is
they have.
only two atoms together to give us a molecule. So that is called intramolecular bond. We can have another atom like sodium atom bonding with another chlorine atom to give us NaCl. This is another what? Another force of attraction between Na and the Cl. So this is also considered an intramolecular bond.
Mm,
So intra means within. So within the same within an atom to form a molecule. Now, the major types of intramolecular bonds. So under intramolecular bond, we have the following. One, we have ionic bonding, or known as electrovalent bonding.
Sir, please can you go back to the other slide? I'm not done writing it.
You have to be fast, oh, Oga. There's no time. Oh, are you done?
Yes, sir. Yes, sir.
Kò sí time, ọ̀gbẹ́ni. Ah, now, so the second one is what? Covalent bonding.
covenant.
This covalent bonding is divided into two. We have ordinary covalent bonding and then the second one is dative bonding. Another name for dative bonding is coordinate covalent bonding. Then the third one is metallic bonding. Now, these are the major types of bonding we have under intramolecular bonding. These are force of attraction that attracts or that binds atoms together in the formation of a molecule. Are we there? So,
Yes, sir.
let's take them one after the other. The first one, which is ionic bonding.
Please, sir.
Any problem?
Sir, what's the last one you wrote on that?
Metallic bonding.
Answer.
Metallic.
Okay. So, ionic bonding or electrovalent bonding. Few seconds, please. My system is booting. Now, ionic bonding or electrovalent bonding, as the case may be, what happens? This is a type of bonding that occurs. This occurs between a metal and a non-metal. A metal and a what? Non-metal. Whereby the metal loses electrons while the non-metal gains electron. So, what do we mean by this? This type of bond is formed between two major entities or atoms. One is a metal, so you have a metallic atom. Let's assume A is interacting with what? B. Are we together? This A is a metal and B is a non-metal. Both of them are now combining together to give us AB. Are you listening? Now,
Yes,
in
sir.
this case, the metal is going to donate electrons. Donate or lose electron. Why the non-metal will what? Gain electrons. So, many a time, how do you identify metals? I've talked about that many times without number. To identify metals, you look at the valence electron. The valence what? Electrons. So if the valence electron is between 1 and 3, that's a metal. To identify non-metals, okay, Ope is waiting. Few seconds, please. But I can't see him here. Okay, I've seen him now.
Sir,
Few seconds, please.
where do you
Okay. I'm trying to admit somebody. Okay. I think he's in now. Are you in now? Olamide?
Yes, sir.
Okay, sorry for the delay. So, yeah, somebody was asking question. What's that?
Meta donates. I can't see what you wrote. Sorry.
I said metal
Meta
donate
donates.
electrons or lose electrons. Donate or lose. This is slash. They lose electron or they why non-metals? They do what? They gain electrons.
They
So how do
gain.
you identify metals? When the valence electron is between 1 to 3. So the valence electron can be 1, 2, or 3. Non-metals. How do you identify them? The valence electron is between 5, 6, or 7. So you can identify metals from their valence electrons and non-metals from
So
the
how
valence
do
electrons. Yeah,
so how do we know their valences?
yeah, what?
Their valences.
We've done that in previous classes. That is through electronic configuration and their atomic numbers. For example, sodium. Is it a metal or a non-metal? From the atomic number 11. So if you write the electronic configuration of sodium, that's 281, right? So
Yeah.
sodium has 281 as the electronic configuration, so it has 1 as the valence electron. So it's going to lose that 1 valence electron. So to lose that, it's going to be like this: Na 1 2 1 2 1 2 3 4 5 6 7 8. Then the last one will be what? 1. Are we together? So since the valence electron is 1, so this is a metal. Now, if it is interacting with something like chlorine, chlorine has an atomic number of 17, so it is 287. So to write the electronic configuration of chlorine, it will be like this: 1 2. The next one will be 1 2 3 4 5 6 7 8. And the last one will be what? 1 2 3 4 5 6 7. This is a non-metal because the valence electron is 7. Are we together? Now, are we
Yes,
listening?
sir.
The metal loses
Yes.
Yes, sir.
electron, so the metal will lose 1 electron because it
Yes,
wants
sir.
to become octets. So octet means it wants to become stable by becoming 8. So for sodium to become 8 easily, it will have to lose this electron so that it can be left with 2 8s and then become stable. For chlorine to be stable, it needs 1 electron to gain 1 electron so that this 7 can become 8. So this sodium will lose 1 electron to chlorine. So when it is losing, the sodium becomes Na plus because it has now lost 1 electron. And so the electronic configuration is now 2 8. Am I communicating? So that will be Na plus 1 2 1 2 1 2 1 2 1 2. So this one is gone now. This shell is gone. Why this other one, the chlorine, that is the Cl negative, Cl, that one is going to be 1 2 1 2 3 4 5 6 7 8. And then since it's gaining 1 electron here, this one will become 8. So 1. The electron it is gaining from this one will come here and become 8. So this one now has gained electron. When it is gaining electron, it becomes negative. That give us um Abdulaziz. You can check my
Sir.
previous lessons on electronic configuration and how to write all this. Is there in the one of the this that I sent where I discuss electronic configuration. Check the videos I sent to you. So I can't go
Okay,
back to
sir.
those classes again. So this will give us 2, 8, 8. Are we together? So you can see that this one is now 8 because it's
Yes,
gaining
sir.
1 electron. This is 8 because it has lost 1 electron. So in essence, when the first ion loses electron, it becomes Na plus, and the chlorine is gaining electron, it becomes Cl minus. Between a metal and a non-metal, there is a force of interaction between the two atoms. So that force of interaction that is connecting them is an electrostatic force. Is what? Is an electrostatic force.
That's it, boss.
3 seconds please. Is So now that electrostatic force is what connect the two ions together, both positive and negative. It's a very strong force of attraction. So it is the electrostatic force that leads to ionic bonding or electrovalent bonding. Does that make sense?
Yes, sir.
Yes.
Now, let's proceed to two more examples of this so that you can get it better before I move to covalent bonding. Now, note I said that covalent bonding ionic bonding exists between a metal and a non-metal. So the metal is identified from the valence electron. So mostly metal are identified from the valence electron. They always have what? 1 to 3, except for helium, except for hydrogen and what? Helium. These ones used to have 1 and 2 respectively, and they are not metals. Apart from these, others are what? Metals. Okay, now if I have a reaction between Mg and what? Oxygen, this will also give me ionic bonding. How do I know that? Mg is a metal. It has atomic number of 12, which is 282. So this is therefore a metal because it's going to lose 2 electrons. Now oxygen is atomic number of 8. This will give me 2,6. The valence electron is
Okay.
6. This is a non-metal. So the interaction between a metal and a non-metal will give us ionic bonding or electrovalent bonding. So if you draw the structure of magnesium, for example, that will give you 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So if you are drawing that of oxygen, that will give us 1, 2. Let me use another sign. Then 6. 1, 2, 3, 4, 5, 6. Are we there? Now, magnesium loses 2 electrons because it has 2 valence electrons. It's going to lose the 2 electrons. Why oxygen needs 2 electrons to become stable? So if magnesium is losing 2 electrons, it becomes Mg2 plus, which will now give us 2,8 because 2 electron is lost now in the process. Am I communicating?
Yes, sir.
Now, so this one will then gain the 2 electrons to become negative.
Yes, sir.
So the first electron here comes to this place, and the second one goes to this place. So in essence, the final or the result will be Mg2 plus now will become octet by having 1, 2. The other one becomes what? 1, 2, 3, 4, 5, 6, 7, 8. Are you following?
Yes,
Why
sir.
the
Yes, sir.
oxygen? The oxygen will be 2 minus because it is gaining 2 electrons now. It should be 1, 2, or like this. Then 1, 2, 1, 2, 1, 1. So the other 2 electrons are coming. This one is here and this one is here. So they are now octet. Both of them are stable. This is 2, 8. So this one is Mg2, 8. And this is also what? 2, 8. Now that they are attained stability, there will now be a force of attraction between them. So the Mg, let me use another pen to do that. Mg2 plus and MO2 minus. Is that okay? Both of them will combine
Yes, sir.
together with exchange of their valencies. So 2 will come down here, 2 comes down here. Remember what we did in some of the previous classes. So it will now be Mg2O2. since there are two, just neglect the charges, you cancel them out. So that will be what? MgO. So this MgO is an ionic bonding because there is a positive attracting to a negative, and so the kind of attraction there is ionic or what? Electrovalent bonding. Is that clear?
Yes, sir. Yes, sir.
Now we can observe many more of these in some other compounds. For example, if we want to identify those compounds with ionic bonding, we have Al2O3. This is aluminium oxide, is ionic bonding because the interaction is between a metal and a non-metal. This aluminium is a metal. You can confirm that from the electronic configuration. This oxygen is a what? Non-metal. So since they are interacting, it is ionic bonding. Am I communicating?
Yes, yes, sir.
Yes, sir.
Yes, sir.
CuCl2 is a metal because this Cu is a metal, ionic bond, and this is a what? Non-metal. So the interaction is what? Ionic bonding. Is that clear? So
Yes, sir.
mostly you can identify ionic bonding when you have an interaction between a metal and a non-metal. So just identify calcium sulfide is going to be ionic because this calcium is what? Is a metal and sulfur is a non-metal. But if you have interactions like this, CH4 for example, the interaction here is not ionic, right? Because this carbon is a non-metal and this hydrogen is also what? A non-metal. So non-metal and non-metal don't combine together to give us ionic. This will give us another type of bonding. Does that make sense? And this is specifically
Yes,
covalent.
sir.
Please, you get what I'm saying?
Yes, sir. Yes, sir.
Now, what are the
Yes, sir.
features or the properties of ionic bonding? So, the properties of ionic bonding, quickly, before I talk about this thing. So, properties, physical properties now. Now, number one property of ionic bonding is that ionic bonding have high melting and boiling points. Or ionic compounds. Let me put compounds. They have high melting and boiling points. Now, before you can melt, e.g., sodium chloride, before sodium chloride can melt and become liquid, it's going to take very high temperature. So the temperature that is required for you to melt a compound like sodium chloride is about 800 degrees Celsius. Pretty high. So on a general note, ionic bonding or ionic compounds um, require so much temperature before they could be melted. So they have high melting and boiling points. Number two, ionic compounds always conduct electricity in their molten form or aqueous form. They conduct electricity in their molten states or aqueous states. So what is the meaning of molten? Molten is when the solid is heated until it becomes liquid. That's the molten state. But aqueous is when you've added the ionic compound into water and it dissolves. For example, when you add sodium chloride in water and it dissolves completely, that shows it is in the aqueous state. But when you heat
It
sodium
equals
chloride,
and
you said,
I can't see that equals very well. Can you spell it, sir?
let me rewrite it. Aqueous state. Ṣé iye wà gan rẹ̀ kò sí iye ń bẹ̀? Okay, EO. Please, it is EO. Aqueous. Now, so when they are in their aqueous state or their molten state, they can conduct electricity. But they don't conduct in their solid state. Don't conduct in their solid state. Are we together? So,
Yes, sir.
and then um, let me add something here also. They conduct electricity via free mobile ions. Conduct current, conduct electricity via free mobile ions. So that's how they conduct electricity because they are like electrolytes. They are electrolytes. Number three is that they are soluble in polar solvents. They are soluble in what? Polar solvents. You know what we mean by polar solvent, ba?
No.
E.g. water. Water is a polar solvent. It dissolves so many substances and it has a dipole. We get to polar compounds very soon under covalent compounds. So, so when you put salt inside water, it can dissolve. So sodium chloride is an ionic compound. Is that okay?
Yes, sir.
Number four is that they always form ions. They form ions through dissociation. So they don't form molecules, they always form ions through dissociation. Just like when you have NaCl to dissociate to give you what? Na plus Cl negative. So this is a very common property exhibited by ionic compounds or electrovalent compounds. Is that right? Is that okay?
Please,
Yes, sir.
can you come again, sir?
Where is that?
The that dissociation,
Yeah.
the place you are explaining,
Yes,
sodium chloride.
I said they often when you have these compounds in water, as in ionic compounds in water, they often dissociate into their respective ions. So meaning they are going to form their respective ions, like this sodium chloride now, right? It has the
Okay.
tendency of dissociating to form ions. They don't form molecules. So they will form Na plus and Cl negative when they are in their molten state or in their what? Aqueous states. You get the point?
Okay.
So that's how they behave. That's their property. Can I proceed?
Yes, sir.
Now, mostly these ionic compounds are always formed in crystal forms. They are always in crystal forms, so we don't need to forget that. Or the crystal lattice. So now, because of time, I'll swiftly move to covalent bonding
They are always in crystal.
in crystal forms. Right? They form crystal lattice. Now, covalent bonding. What does that mean? It's also a form of intramolecular bond, but this one involves, it occurs between nonmetals. This type of bonding occurs between what?
Non-metals.
Nonmetals. Strictly nonmetals. Where electrons are being shared. Where electrons are what? Being shared. To attain stability. So note, in this case, the electrons are not, there is no transfer of electron in any way or gain of electron. It exists between nonmetals only, and it involves the word sharing of electrons. So electrons are being shared, and these electrons are being shared either in the what's it called, right proportion or not. So I need to explain that quickly. So from here we have what we call the ordinary covalent bonding. So under ordinary covalent bonding, we talk about, let me use another term now. We talk about non-polar covalent and we talk about what? Polar covalent. I hope you are listening. Now,
Yes, sir.
I will give you some examples to understand these illustrations. Then I will distinguish between polar and non-polar covalents. Now, normally, when we have an atom like hydrogen, hydrogen has just one electron, and so hydrogen can be represented this way. Now, if I have another hydrogen, which is also represented this way, both of them wants to share, because they are both non-metals now, because we said hydrogen is one of the exceptions. Hydrogen is a non-metal that has one valence electron. So let's say these two hydrogen now are trying to share electrons to become stable. So the first hydrogen is going to come this way. Few seconds. Few seconds, please. Okay. Now the other one too will come here to share electrons with it, because now they want to become stable, so they will share one electron. Now what happens ordinarily is that this hydrogen, the first hydrogen, needs one electron to become stable, because hydrogen will exhibit duplet configuration. Duplets. Duplet configuration means that it needs just two electrons to become stable. So that's duplets. Are we together?
A duplex what?
Duplet state or configuration. So hydrogen needs just two electrons to become stable. It does not need eight. So that's why we say this is going to have, hydrogen will have a duplet state. Now it means that this first hydrogen will be duplet, and this one too needs to be what? Duplet. So in an attempt to be duplet, this one needs one electron to be complete, and the other one too needs one electron to be complete. So they will share both electrons together. Bring your own electron. Let me bring my own electron. Let's share it together. So when they share it, they form this. So the electron they are sharing together is what we call the bonding electrons. Bonding electrons is what? Electrons shared for stability. hope everyone is listening.
Yes,
Yes, sir.
sir.
Yes, sir.
So electrons shared for stability, that's called the bonding electrons. So when it is in pair, pair means in twos. Pair means what? In twos. So we can have what? We can have bonding pair, and we can have bonding pair. So in this case now, the bonding pair can be represented using one arrow like this. That means we have two electrons bonding together. So you can see these two hydrogen, the way they are, I can represent them using what? H, right? With a bond in the middle and another H.
Yes.
Please let me say something. If you don't understand this class very well, I'm trying as much as possible to explain. And I'm recording this section. I know it's a bit technical. If you don't get it, I will compress the video. I will send it to the group. Go and watch it very well. It's very important. Do you hear what I said?
Yes, sir.
Yes,
I
sir.
don't.
Now, so these hydrogen are actually sharing one electrons together to give us one bond. And because they are now shared up together, they now give us H2. That's hydrogen molecule. So this is how these bonding are formed, by sharing these electrons. So let's look at more examples to get a better understanding. Now, if we take a look at another um, piece of non-metal like 2 chlorine, we have chlorine atom and another chlorine atom to give us what? Cl2. Now this is also covalent. Why is it covalent? Because it's existing
They are
between
no.
non-metals.
Yes, sir.
Nitrogen chlorine is a non-metal, and this is also another non-metal. Now both of them are trying to interact together by sharing electrons. This first chlorine is 17 electrons, so it is having 2, 8, 7. So I'll represent it using the last electron only. The last electron is 7, so let me use the last electron. 1, 2, 3, 4, 5, 6, 7. Are we together?
Yes, sir.
The second chlorine is also having what? Cl17, which is 2, 8, 7. It's also having 7 electrons. 1, 2, 3, 4, 5, 6, 7. How many electrons does this first chlorine need to become stable?
What?
1 electron. So to attain stability, it needs 1 electron so that this 7 can become 8. How many electrons does this other chlorine needs to become stable?
One.
One.
1.
1. So because they both need 1 electron, they will
Three
share the 1
combined.
electrons. Bring 1, let me bring 1. So the first chlorine will bring his own 1 like this. So the second one too will bring his own 1 by sharing with this. This is my own 1 here. Are you getting it?
Yes,
Yes,
sir.
sir.
So after they are sharing, you realize that in the middle, we have the what? Bonding electrons. The electrons they are using to bond with each other. That is this electron. So that is called the bonding pair. Does that make sense? So because you
Yes,
are
sir.
having
Yes,
just
sir.
2 electrons, that 2 electrons will form one bond
Yes,
like
sir.
this. So this implies that my chlorine will become Cl single bond Cl. Are you getting it? Why do I have single bond? Because I have what? 2 electrons making a bonding pair. So 2 electrons will give me what? One bonding pair like this. You get the point?
Yes, sir.
Now you can see the all other electrons around it. They are called valence electrons. So where are the valence electrons?
So,
All those electrons that are not bonded. Yes. Are you saying something?
that two electron you wrote here is equal to. Can you explain it more,
Which
sir?
one?
The two electron that there's
Okay.
minus on it. Can you explain
What
it
is
to me?
happening? Few seconds, please. My screen has gone, and I've been trying to save this thing. Let me see if it is saved. It's saved. Few seconds, please. As if I knew I would have this issue. Few seconds. Surprisingly, the thing did not save. Okay, no problem. But I think you should see it in the videos, however. So, what I was trying to say, let me explain again quickly because I said you have one chlorine atom with another chlorine atom. Are we there?
Yes, sir.
17, 17. Both are non-metals, so they will bond to give us what? Cl2. So that's
Yes.
covalent. The electronic configuration of this is 2, 8, 7. And the electronic configuration of this is 2, 8, 7. Now, if they are to bond, this one, let's assume this is it here. 7 valence electron is like this. The other one too has 7 valence electron, which is like this.
I'm not seeing your screen.
Oh,
I'm not taking your too.
I'm not saying it.
let me share. I did not share it. I've forgotten, please. Sorry. Can you see it now?
No, sir. Yes,
Yes,
sir.
Can you see it?
Yes, sir.
yes,
Fine.
sir.
So this first one needs one electron to become stable so that it can become 8. This one too needs one to become stable so that it can become 8. So
It's
this one will say, give me one now. The other one will say, give me one. I cannot give you. So yeah, let's share together. Bring one, let me bring one. So the first one will be like this, right? Then the second one too will bring his own. Since you are sharing, it will share the own one too. You can see that they are both sharing one together here. So
yes.
the other one is like this. Now the point where they are sharing, this particular point where they are sharing, that is called the bonding electron or the bonding pair. You get that?
Yes.
Now because they are in twos, so we call
Yes,
it
sir.
bonding pair. Because they are in twos, we call them what? Bonding pair. Because a pair means two. And you represent that bonding pair using hyphen like this, hyphen. It means that there is a bonding pair there. So the first chlorine, right? This is the first chlorine. This is the second chlorine. Both of them are now bonded together using what? A single bond like this. Right? Because that single bond here is representing the two electrons here. That is the bonding pair. Is that clear now?
Yes, sir.
So all other
Yes, sir.
electrons around it, we call them lone pair of electrons. All these ones you see here, they are called lone pairs of electrons.
L-O. Okay.
Lone pair, L-O-N-E. We call them pair because they are in twos, right? So, and
Yes,
they
sir.
are not involved in the bonding. So that's why we call them lone pair of electron. Are we together? Now,
Yes, sir.
you can see that
Yes,
yes,
sir.
you can see that Cl2 and the first one we talked about, which is H2, they are made up of the same atom. So they are said to be homonuclei molecules. So they are formed from what? The same atoms. So since they are formed from the same atoms, they form an homonuclear molecule. And homonuclear molecules are always said to have what? Linear. They are going to have a shape, and the shape is what? Linear shape. Linear what? Linear shape. So in case you are asked the shape of any compound that is
Sir,
homolinear, like Cl2,
sir.
yes, H2, O2, N2, since they are all of the same molecule, I mean the same
So
atom,
if they all have the same molecule,
yes, they are
they are
all of the same,
homonuclear molecule.
yes, we call them homonuclear molecule, and all of these
Okay.
homonuclear molecule are linear in shape. The shape is linear.
The number under them is their what, sir?
Which
Under
number?
the
Which
element.
number?
Under the under maybe the hydrogen, maybe
I'm not getting that.
the chlorine,
Uh-huh.
the two under it. What number is it, sir?
The two. I'm not get. Okay, you mean these ones? These two
Yes.
here. It
Yes, sir.
shows
Yes, sir.
it shows that you have two of these atoms coming up together to form a molecule. So they are all diatomic. They are all
Okay.
diatomic. Diatomic
Okay.
means two atoms are coming up together to form their molecules. All these
Okay.
compounds are homonuclear molecules, and then they have a bond angle of 180 degrees. I will take part of your time today. Oh. Please don't be offended.
Okay.
I want to do this thing to a reasonable extent because of the assessment. If we don't do it like this, we might not be able to finish the syllabus. Are you listening?
Yes, sir.
Hello?
Yes, sir.
Yeah, so now don't forget the shape is linear and the angle is what? 180 degrees. Note that. Now I'll pick few other ones to see how they relate that are still also homonuclear. Let me look at oxygen now. One oxygen with another oxygen bond together to give me what? O2. That is oxygen molecule. Are we there?
Yes, sir.
Now, oxygen molecule, oxygen, one oxygen atom is 8 and the electronic configuration is 2 comma what? Comma
Eight,
6.
6.
So the other oxygen 2 will be 8 and it is what? 2 comma 6. Now, how many electron? Let me write this one first. This is, I'm going to write only the valence electron. 1, 2, 3, 4, 5, 6. Right? The other one too is 6. 1, 2, 3, 4, 5, 6. Are we together?
Yes, sir.
How many
Yes,
electrons
sir.
does the first atom needs to become stable?
Two.
2. So this one needs 2 electrons. How many electrons does this one needs to become stable?
2.
2 electrons. So this one is a bring 2. Let's share the 2 together. So they will both bring they will both bring their 2s and they will share. The first one will bring his own 2 like this. This is my own 2. So you don't forget it is 6. So the other one too will bring his own 2 to share with it. This is his own 2. This is my own 2. Are you following? So
Yes, sir.
Yes, sir.
this is 6 also. Now if you look at them this way, you realize that they are now octets, meaning they are now 8. If you count the total number of electrons in this one is 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is stable. 1, 2, 3, 4, 5, 6, 7, 8. This is also stable. You can see that it's now stable. Now you realize that we have the bonding electrons in the middle here. Can you see the bonding electron in the middle?
Yes, sir.
How many electrons are there?
Yes,
4.
4
sir.
electrons. Now, and we said that 2 electrons make one bond
Yes,
like this. So 4 electrons will make how many bonds?
Double bond.
Double bond. So oxygen will now be O, double bond O. Can you see that?
Yes, sir.
Now, the other electrons, these are the lone pairs of electron. The lone pair of electron we just have what is it called? Lone pair like this: 1, 2, 1, 2, 1, 2, 1 2. Not necessarily though, but you need to know that they have lone pair, right? So we have two bonding pair here, two bonding pair of electrons. And how many lone pair do we have? If you look at the lone pair, 1 2
4.
1 2, that is 2 here, 1 2 1 2. So we have 1 2 3 4. We have four bonding, I mean you have four lone pairs of electrons.
Okay, sir.
Does that make sense?
Yes, sir.
Yes, sir.
What's that?
Yes, sir.
Now let me pick one more example here. So we now have n, so we have nitrogen plus another nitrogen to give us what? N2. Now the first nitrogen, if you check the atomic number, it is 7. So this will give us 2 comma 5. So nitrogen is like this. The valence electron is 1 2 3 4 5. Are we there?
Yes.
The second one too will be
Yes, sir.
like this. Nitrogen 1 2 3 4 5. Are we together? Now, how many electron is needed by this first nitrogen to become stable?
3.
Two.
3.
3.
What about this one?
3.
3.
Zero.
So they will both share 3 electrons. The first one will share its own 3 electrons like this.
Sir,
Yeah,
I'm sorry for the question, sir.
go ahead please.
How do you know that um the remaining electron will be three, sir?
Now
As the
look at
answer?
this. The valence electron is what? 5.
Yes.
So it needs to gain electron because it's a non-metal. How many electron will it gain to become octet, which is 8?
Now that's one.
No. You are not looking at this one, 2 here. You are looking at the valence electron, 5.
Okay.
So because the valence electron that will be 8 before it can be stable. So it is having
Yeah.
5 valence
Remember
electron. How many electron is needed for it to be stable?
three.
3. Can you see how we got the 3 now?
Okay, sir.
Now, so they will now share 3 electrons. So the 3 electron that this one want to share, this is it. This is now having their own 2 like this. So the other ones too comes this way, and that one too will share his own 3 electron. 1 2 3. Can you see that? Don't mind the way I'm drawing it, just
Yes,
get
sir.
the idea. So then 1 2. So if you count the electrons, they are now stable. Now if you look at the midpoints, the bonding pair, you're having how many electrons there? 6
Six.
electrons. So 6 electrons will give you how many bonds? If
3
2
to 1.
Three
electrons,
bonding pairs.
good, thank you. So it's going to be like this: nitrogen, 1 2 3, nitrogen. So the first one you have like this. So it is having 3 bonding pairs, and it's having what?
So the call is
2
about to end.
lone pair. Oh,
How
let me let
zero?
me let me send another one, please. I cannot end like this. I cannot stop here. Oh. I want to stop to a very reasonable part so that when I finish the video, you can revisit it. This aspect is a very important aspect of chemistry. Okay? Subhanallah. This part has not been recorded of my class. So, la ilaha illallah. Hey. Okay, it's recorded. It's recorded. I thought it was not recorded. Jara mo fún wọn Jara. Hello, Mama,
Sir.
can you hear me?
Yes, sir.
Okay, I want others to join quickly so that I can finish in a reasonable place.
Okay, sir.
If you don't do it this way, we will not be able to complete the syllabus and it will not be too okay.
Yes, sir.
Are you tired, Mama?
Yes, sir.
I know. What did you do that you are tired? Are you cooking? Eh?
I'm tired.
Why are you cooking? Are you cooking that you are tired?
Yes, sir.
You don't know what is doing you. You think jam na play play abi? Jam is not play play. You must be serious and you must be committed. I'm waiting for others to join so I can continue. Let me continue. If they are not joining, they will meet it maybe in the video or something. Now, I was trying to explain this part. Can you see the screen? Oh, I've not shared it. Let me share the screen, please. Can you see it now? So, this compound is having how many bonding pairs? 3 bonding pairs. Are you listening?
Yes, sir.
See, that's why I always want these people to join on time. Eh? Let me admit. I don't like going back to this thing to admit. So, where am I? Now, so you can see why it is having 3 bonding pairs and then 2 lone pairs, right?
Yes, sir.
Now, get what you are going to get here now is that you realize that the hydrogen, for example, is H11, right? It has one lone pair, one bonding pair, with no lone pairs at all. Cl2, chlorine, is Cl single bond Cl. If you check what you've done, I want to, are you listening? Oxygen,
Yes, sir.
O2. That one is what? That one is oxygen double bond O with 2 lone pairs. Who is trying to enter again? Oh, enter quick now. Me too, I'm tired now. But I must finish this thing. Why you don't want me to finish it? Everybody is tired now. We will have to finish it. Who is that again? Hey, these people are the ones that are delaying me. They are just entering 1-1. How can you be entering 1-1? Cannot join at once. Oh. Okay. Now, so you can see that oxygen is having double bond and nitrogen is having what? Triple bond. Who is that again? Ah,
Yes, sir.
who is that one again? Everybody has joined now. Mazida. Ṣé mo ti admit ẹ̀ ń sìn? Kí ló ń ṣẹlẹ̀? Now, what is the implication of that? You can use that to detect the number of lone pair and the number of what? And then bonding pair. So this one is having like this, like this. So now you get to realize that the more the bonding pair, the higher the boiling point. Note that the more the bonding pair, the more the bonding pair, the what? The higher the what? The boiling point. Are we together? So it means
Yes, please.
anyone that has triple bond is having more force of attraction. So the force of attraction binding this nitrogen atom together is greater than the force of attraction binding oxygen together. Because oxygen is all binded by two bonds. Nitrogen is binded by three bonds. So the bonding of nitrogen is more. So that means you need more energy to break the nitrogen molecules. Now, you need less energy to break hydrogen molecule and chlorine molecule than you will need energy to what? Break oxygen. In oxygen, you will need more energy to break the molecules of oxygen than you will need for chlorine because oxygen has two bonds. Is that okay?
Yes,
So I
sir.
don't.
Now, I want to take like the next, what's it called?
Guys, I don't
Five
understand.
minutes to complete whatever I want to do for today. So I'll just take 5 minutes of your time. Now, if you have listen, hetero what? Heteronuclear molecules. So these heteronuclear molecules, they are molecules of different atoms. They are made up of what? Different atoms. So, for example, HCl. Are we there? H2O, NH3. Are you listening? CH4.
Yes, sir.
I will only talk about these four substances. Right? So, now the first one for today, I will just talk about these four. Now, the first one, HCl, look at the bonding. Don't forget, you said you have polar and non-polar. All what I have discussed above there, they are non-polar. All these ones are what? Non-polar. Right? I would later distinguish between how to identify polar and non-polar compounds. So now, this HCl now, it is between hydrogen and what? Chlorine. So how is that done? We know hydrogen is just one electron. So hydrogen is like this, H with one electron. Are we there? But chlorine is 17 with 287 with 7 electrons outside. So chlorine will now be what? Cl 1, 2, 3, 4, 5, 6, 7. Are we together? How many
Yes, sir.
electrons does hydrogen need to become stable?
7.
Like, you
One.
said it will need just one because it is duplet. Hydrogen is always duplet. Is that clear? How many electrons will chlorine need to become stable?
One.
One. So they will share one one. So hydrogen comes here, brings its own one. Then chlorine 2 comes down here with its own one. They share together. So it will now be like this. Are you following? So it will now be H. This one is the bonding pair. One like this way, and these are the lone pairs. Is that okay? Now, this is going to be a linear shape, right? And then it has a bond angle of 180 degrees for HCl. So HCl, anything linear is 180 degrees, okay? So it has one bonding pair and three lone pairs. So let me look at the second one, H2O. Let me take H2O quickly and then the others. Now, if you are looking at we are considering H2O. H2O is made up of what? Hydrogen, two hydrogen atoms, right? Plus one oxygen. Are you following? So the oxygen is like this. Let me use this. H2O. So you have two hydrogen plus what? One oxygen. So this is the oxygen. 8. That is 2 comma what? Comma 6. So this is how oxygen would be. 1, 2, 3, 4, 5, 6. Are we together?
Yes, sir.
Now we have two hydrogen. The first hydrogen is like this, H with one electron. And the second hydrogen like this, H with one electron. So how many electrons does this oxygen needs to become stable?
Yes.
It needs two, Abi, because it is 6
Yes.
valence electron.
Yes.
How many hydrogen does this one needs to become stable? Electron does this need to become stable? 1.
One.
This one too
One.
needs 1. So they will share
One.
their 1 1 to this oxygen so that oxygen can have 2. So it will now be like this. This is my oxygen. So you have 1 2 1 2. Don't forget you have 1 here 1 here. This one will come and share electron with this, right? And this one will come and share its own with this. So at the end you are going to have what? You are going to have this. This is oxygen with 1 2 3 4 here and here. So the first electron of hydrogen comes here, bond with this. It is sharing 1 1 now. This one comes here, bond with this, sharing 1 1. Are we together?
Yes, sir.
Yeah, I don't understand, sir.
Which part don't you understand? Yeah.
The last part, sir.
How? What is the valence electron of oxygen?
6,
How many electrons does oxygen need to become stable?
2,
How many electrons is there in hydrogen? Valence electron.
1,
How many electrons
1,
does it need to become stable?
1,
How many hydrogen do we have?
2
2.
hydrogen.
Now, the two hydrogen are now having 2 electrons. They want to be complete. So since this has to do with sharing of electrons because they are non-metals, this hydrogen here will come and share with 1 electron of this one here, so that it
Okay.
can share to give this one electron since it needs the other one too, that this one needs 1, it will come and share with the one of this one here. So when they are now sharing together, the 2 electron that the oxygen needs has been accommodated from this hydrogen, and this hydrogen the hydrogen 2 that needed 1 electron each, they have accommodated from the oxygen.
Okay.
Do you
Okay.
understand that?
Yes, sir.
So at the end they will now have you this way. Oxygen is now like this, bonding, because this is the bonding pair here, this is another bonding pair here, so they will form 2 bonding pairs with hydrogen like this. Can you see that? And these ones are
Yes,
bonding
sir.
pairs. These ones are not like this. You get that? So this is the
Yes, sir.
shape of water. The shape of water is, you call it bend shape. It has bend shape, or what? Or V shape. Are we together? Or what?
Yes.
Angular shape. That's the shape of water. It's either bent, V shape, or angular shape. The bond angle of water is 120 degrees. That's the bond angle of water. Is it clear now?
Yes, sir.
Now, how many am I left with? I'm left with 2 more molecules. I must finish it today, sir. So, what are the 2 more molecules that remain? Ammonia and CCl4. So, let me quickly do that of ammonia. Ammonia is NH3. NH3. So, it is formed from nitrogen and what? 3 hydrogen, right? So, the nitrogen here, atomic 7, that will give us 2 comma what? 2 comma 5. Are we together?
Yes, sir.
So the valence electron will be like this: 1 2 3 4 5. Am I communicating? So
Yes, sir.
Yes, sir.
one hydrogen is H, and it is having X, right? It's having 1
Yes.
electron. How many are they? 3. This one will have like this, and this one will be like this. Now this one needs how many electrons to become stable? The nitrogen.
Means
The nitrogen needs one how many
one.
electrons to become stable?
Theory.
3 now. Nitrogen. It is 5 valence electron. It needs 3. So these ones now they need one abi to become stable.
Yes.
Yes.
So they will come and join one with them with this one. This one will come and join with one of this. This one will come and join with one of this. This one will come and join with one of this. At the end, it has accommodated for 3 electrons from the hydrogen atom, and the hydrogen too have accommodated one electron from the nitrogen. So it will now give you this at the end. You are going to have the nitrogen this way. Are we following? So
Yes, sir.
with what? This one, this one, this one, this one, this way. So you are now going to have this one is coming bonding with this. This one is coming bonding with this. You have one left. This one is coming bonding with this. So at the end, you have accommodated for the all the hydrogen 1111, and the nitrogen is now stable. If you count the electron, it's now 8. So you now have it this way: nitrogen. This is a bonding pair. This is a bonding pair. This is another bonding pair. How many bonding pair do you have? 3. So it will now be like this. Later, I will talk about shapes and molecules to know how these things are coming. So this is now like this. Are we together?
Yes, sir.
Yeah. So it is having 3 bonding pairs and what? 1 lone pair. Does that make sense? So
Yes, sir.
this is ammonia. Ammonia. The shape of ammonia is trigonal pyramidal. Trigonal
Are you still
pyramidal.
writing on the screen, sir?
Yes, I am. Can't you see it?
It's not showing. It's not showing here.
Are others seeing it?
Yes, sir.
I think it's your network.
I'm not.
Trigonal pyramidal. Don't worry, it will come up. So the shape of ammonia is trigonal pyramidal. What's the bond angle? The bond angle is 10 trigonal pyramid. I think that should be 107 if I'm not mistaken. That should be 107 degrees. So is that okay now?
Yes, sir.
So that is that. Finally is methane. CH4.
Don't
CH4.
say this.
That's the final one for today. I know I've taken so much of your time, but I think Nibinu Kole Danoni. So now for the final one, which is what? Methane, CH4. Methane is CH4. It is called methane. So it is formed from what? 1 carbon plus what? 4 hydrogens. Right? So
So I cannot speak. Yes, sir.
there's nothing wrong with mine. What about others? Can you see it? I think I'm still sharing.
Yes, sir.
Can others see the screen?
Oh.
I see it now.
Yeah, I think it's your network. Now we have 1 carbon, right? And 4 hydrogen. So carbon is atomic number of 6. That is 2 comma 4. So that's going to be carbon like this. It's having 4 hydrogen. 1, 2, 3, 4. Are you following? And hydrogen now is just like this. How many hydrogen do you have? 4 hydrogen. Are you getting it? Olamide, are you there? Is Olamide there? Dean, are you there? Mama. But you lose network now.
So we can see it now.
I think I have issues with my network. It's my own network that is doing bad.
I can see it now.
You can see it now, Abi. Let me quickly complete it
Yes.
so that everybody can leave.
No, I'm not saying it.
It will come up. It will come up. So let me complete it, please. So now that these are having 4 carbon, you can see that how many electron is needed for carbon to be complete, to be stable?
Four.
4. So it will not share one. This one will share with this one is sharing this one is sharing this, and this one is sharing this. So at the end you will now have something like this: the carbon atom sharing electrons all around it, like this, like this, like this. So the first one, you're having 2 seconds. Dean, are you still there?
Yes, sir.
Yes, sir.
Okay, okay, okay. Mo bí ó ti
I'm
sùn.
not seeing the screen.
You are not seeing the screen. Yeah,
Rejoin.
Yes, sir.
yeah. So it's like this. Rejoin, rejoin. I think it's visible. It's clear now. So though I'm done already. So it's like this, and it's like this. Can you see it?